Should we get started? What do you guys think?
Yeah, let's do it.
Yeah.
All right, cool.
Yeah, let's do it.
Word. So, I'm Austin at Ethereum. Hey guys, how's it going? And I'm kind of like a builder in the space. So I'm always trying to find groups that are getting ready to build stuff and talk with them, right? So I'm kind of like a tool maker, and I think of myself as an educator. I try to stay away from that like thought leader kind of stuff because I'm an idiot. But I'm a tool maker and an educator, and I am focused on like UX and DX, trying to make sure that people don't rage quit building on Ethereum. So I kind of have a product focus too. Like I don't know. It's the way my brain works, just trying to get people to use stuff and kind of iterate on that. And I'm at Austin Griffith on Twitter and Telegram. Hit me up anytime. Reach out about anything. Really, what I fell in love with was like the greeter contract in Ethereum. Like very, very old school, right? You guys F with the Wayback Machine. Check this out. I went to the Wayback Machine and found like 2000. I think it's like 2014, 2015. This looks really cool. Like, but this in here is the greeter bot, right? Isn't this cool? Yeah. So, but it's funny. It's like what you need. Well, you're going to need to like run your own node. You're going to have ETH to like upfront to even participate, right? But in here, like I loved the greeter contract. If I go back to this, it has inheritance in it. Like the very first thing developers are hit with is this code snippet of a smart contract with inheritance. And I actually kind of love that because it kind of, as a programmer, you kind of like get that and you see that. But we're kind of talking no code here, but code is very important in the Ethereum world. So I will do a little coding here. But this idea is what I fell in love with. And if we simplify it down to just a smart contract wallet where it has an owner and it can kind of receive funds and you can withdraw, you start to think about, oh, this is like a thing that exists out on all these machines and there's no centralized figure, right? So that really got me into it. But I had to like build and throw away a lot of projects. I like to say that leading up to hackathons is just like, you got to iterate, and sometimes you're going to throw stuff away. Like sometimes it's best to not be married to a specific project, and I'll just like wail through all the things that I've built and thrown away. But it's this process, right? You kind of go through this building process and you iterate through and you get things in people's hands and you see how they use it. We could talk about the DAO a little bit. Someone gave that a shout out earlier. But the point is, going into this, you want to be able to prototype and try things and be able to get straight to building things. And I'll kind of crush into that in a little bit. But first, we should probably start with like ETH.Build, and I'll do an introduction to how ETH.Build works. But then after that, we'll do Scaffold ETH, and we'll look at like building a dApp and kind of like a smart contract sandbox. Let's go build. Any questions to like get it started off, or anything anybody wants to get out of this particularly? We already kind of asked that question, but I want to re-ask it just in case someone's got something. Okay, I'm going in here. Okay, so ETH.Build. You guys see ETH.Build? You see it on the screen? Yes, am I doing it right? Elder
I see it slide.
Figure out the technologies
for you. Yeah, and just so for anyone else, if you do have a question, feel free to pop it in the chat just above this, the general discussion channel, and Austin can address it as he goes through his presentation.
Oh, so you see the slide. Which slide? You see the build slide, right? But then when I smooth over here, you got
there we go. ETH.Build. Yep.
Okay. Did it just now come up? Oh shoot.
Yeah. I was looking. Okay. I think it was fine. I was looking at the preview, not the actual slide.
Man. Okay. So did you? Whatever. Let's just get into ETH.Build, right? Okay. So run it. Let's go. We're doing it live. Okay. So we see it. Let's see. I'm moving. Yes, we're good. Okay. So ETH.Build is like a prototyping language where you can get in and kind of just get your hands on things and kind of poke around with Web3. In cryptography, it's kind of hard because you either get it completely right or you get it completely wrong. And it's so hard to figure out what the heck is going on. And sometimes it's nice to be able to just like poke around and kind of check some assumptions. And that's what ETH.Build is really cool for. I've used it as kind of like an education platform. So I have like a YouTube channel, and I go through just like from the beginning what a hash function is, key pairs, transactions, encryption, distributed ledger, Byzantine generals, blockchain transactions, and smart contracts. But you can go to learn more. You can check out the channel. But let me just dive in. Let's see. Okay, cool. Here we go. We have an ETH.Build. Everybody can see it. Okay. Wait, is it paused? Oh, they just paused the preview. Okay, I get it now. Okay, you guys are seeing what's going on here. All right. That's good. This elder millennial, I'm telling you, this new technology, I got to figure it out. Okay, here we go. So what I have here is an ETH.Build where let's just start from scratch, I think. Actually, so what I was going to do here is have to see if people could send in, and I don't know if they could, but basically this is an ETH.Build that's watching some account. And if I click through, I'm just going to pick some random account, that orange guy right there. How hard would it be for the crew here, everyone here, to basically shoot this QR code and send, I think I have, what is it, Rinkaby, XDai, and Kovan? Like, do you have the means to do that pretty quickly? Or even like probably you would want to copy, right? You'd want to be able to copy this and paste it into chat. Okay, I was going to drop some funds into this, but maybe we'll do that in a little bit. I think we could start with like some very basic. So if you open up, let's see, this isn't going to let me. If we open up the Sandbox in incognito mode, you'll get, here we go. Let me see. I can't tell if, let's see. Let me see if I can see it on, nope, I can't. Okay. If you open it up in incognito mode, you get like this kind of teaser screen that tells you all the different stuff you can do and drag around. I'm just going to start with a blank screen. You can just basically Control A and delete everything, or you can hit that button and that button. But let's clear it completely out and start with just like a hash function just to see kind of how this works, right? So we know like a hash function just kind of like flows this way. It's one directional. It's deterministic, right? So this works as a really cool teaching platform because I can show people kind of very viscerally how I'm dragging stuff around. And let's change this to hello world. And we know that like, if I type world here, those are going to match up, right? It's deterministic. This can be any size, right? Okay, so you can learn all the stuff from ETH.Build down here. I've got hash function key pairs, all the stuff we mentioned earlier. There's videos that go along with the building. But let's go back to, let's see. Let's start with the curriculum kind of covers what you can do with, get that arrow out of there. What you can do with a key pair. And I think that's a really cool thing to kind of just like touch on real quick. So if I go and generate that address, right? Like anyone can participate in Ethereum with just that address, right? You generate some random private key that no one can ever guess statistically. And then from that derives who you are, your address that you're going to transact on. But what you can do with that is really powerful. You can, in a kind of weird way, you can encrypt and decrypt data, right? So for someone's public key, I can send some information to them that only with their private key plugged in here could decrypt that data. But more importantly, there's this sign and recover, right? And what can you do with sign and recover is really cool. Is like, well, what if we start like signing objects that's Alice sending money to Bob, right? And then we can kind of bring in a distributed ledger where Alice, is sending money to Bob and we're tracking it, right? And then obviously when you start talking about a distributed ledger, like then we're all keeping, Alice and Bob and everyone else, they're all keeping copies of this and we're signing and recovering these, and all of a sudden we've got transactions and that leads to the Byzantine generals and consensus problems and eventually, the discovery of blockchain. This is really cool though. If you get into the Byzantine generals, you can see General Bob here. And he's working really, he's got a bunch of soldiers working really hard to try to find a hash with leading zeros. So then he can prove his attack plans to attack Monday at dawn. It's a fun episode. Get in there with soldier toes and some weird stuff. It's a lot of fun. But eventually we get to smart contracts, right? We can actually, let's load it up and look at it. We can actually type some code and we can compile and deploy that code to a test network and we can poke at it. But This is where I was thinking we would probably actually write some code or kind of play around with scaffold ETH. And then maybe for like the last half an hour, we could do like just open whatever. Maybe we could poke at the DAG or whatever. Someone mentioned that. I'm up for whatever.
Yes.
Word. So is there like a text chat going on too at the same time, or is it just this and we're talking out loud? Like, what's the format here?
There's a general discussion right above this audio channel where people can drop stuff, but
okay.
So far no one's dropped anything. I dropped the DAO because it's awesome, but like otherwise, yeah.
Awesome. Okay, cool. Okay, so so you can really poke at a lot of things with ETH.Build, but I think that if we are going to poke at smart contracts, I'd like to, let's see. So I'm not sharing I'm going to have to switch the way I'm sharing my screen. Just a second. Let's try this a different way. Oh yeah. Oh yeah. Here we go. Boom. Okay, now we got like a screen, right? Yeah, check out this cool. Doesn't this look very Ethereum-y? This little background, isn't that neat?
Oh, do you guys see? That's like the Ethereum for kids.
Right, right.
D stands for decentralization.
Word. Okay, so we'll leave this guy here for later, I think. And we'll go to Scaffold ETH for a little bit. So Scaffold ETH is like it's not really a product itself. It's more like my stack for hackathon developers, right? It's like a quick down and dirty stack to be able to get something prototyped quickly that runs with a smart contract backend. And like I said, it's not really a product. It's more of a combination of Biddler and Create React app. So two like really good products already. Lots of great development going on with both. But really something important about them is their focus on developer experience. They're just better to use. They're a lot better to use. So in particular, like when you're compiling and deploying on a Biddler chain, you can get console logs back from your smart contract, and we'll get to that in a second. So let's just like do the quick. So there is a quick start, which is really cool. There's like a to-do list that you check off. And I did that yesterday, but I think today I want to do the quick iterate on smart contracts. So it's like the smart contract sandbox. So this is a way, sort of like probably what a lot of you think of for Remix, where it's like I've got some solidity and I want to like just kind of tweak it and play with it and see how a certain thing works, right? A lot of you probably do go use Remix, and that's a good plan. But this will be more of like a local environment, like a local template of a dApp where you're doing that same thing. So let's just get started here. And if there's any question, just like shout them out. Get up on the audio. So I'm going to bring this in, make this bigger. Hopefully we can see. So the first step is just cloning down the repo. And we'll CD in there. And just a double stamp, a triple stamp. So I went to the Scaffold ETH repo, which I could just paste into chat. Let me do that. Bam. Okay, so now we got that in chat. Now I can click and go back here. Look at this. I'm a wizard with this now. I love it. Okay, so I went to there, and then I went to Smart Contract Sandbox. Okay, so you go in and you clone and you CD in and you yarn install. And this is going to take a little bit because there's a ton of dependencies. So while that's going, we'll just kind of like look at the file system for a second and see that you have like these two main packages, and that's the Biddler package and the React app package. Sorry, that's so small. But you probably, some of you will have to maybe trust me if you can't see the resolution there. But there's a Biddler folder and a React app. And really what we're going for is our smart contract right here. And I can make that bigger. Pop, pop, pop. And our popping and flopping. And our app.jsx. There we go. So this is kind of our front end. This is our smart contract. These are the two things that we are going to iterate on here as soon as this guy gets done installing. Looks like we're about halfway done.
I'm going to TM popping and flopping, by the way.
Do it for sure. It was great. And it's true, like this bow tie is actually like extra floppy as far as bow ties go. It's definitely like kind of a flopper. Okay, so here we go. So you might get this node jip error depending on what node version you have. I feel like I go back and forth between 10 and 12 and 14. I really do have like 10 and 12 and 14 like right on my desktop, and I'm switching installers. But so you may get a node jip error, but totally ignore that. You need to just do a yarn start, and the React app will come up eventually. But don't get too distracted because you'll also want another terminal. And this is right here in the instructions. So the first terminal was our yarn start. We've got that running. Our second terminal will be a yarn run chain. And this goes and fires up a Biddler node. So like Ganache, it's a blockchain with private accounts and everything for you right here. You can talk to it at localhost 8545. But this guy has the EVM rebuilt by the Nomic Labs guys. And so you've got lots of console logging and lots of debugging, and we'll get to that. But it's really nice to have this here, and we fired that up with yarn run chain. And then the last thing we'll do is a yarn run deploy, and that will compile and deploy our contracts. But something a little extra, it's going to inject the contracts, the artifacts into our front end. So here we go, our front end app is coming up and it's telling us, you need to run yarn run chain and yarn run deploy. So we've got our chain up, so let's deploy. This will compile our smart contract right here, give us some weird warnings, and then hopefully deploy it over here. So what is it, 7C, 2C? Yeah, reloading, 7C, 2C. Okay, so now we've kind of got this dev loop we can mess around with, right? So we can, what was it? We're like 5 minutes in maybe. So the installation took a while, but in 5 minutes, I know you could have gone to Remix, but now you've got a development environment up and running, and you have your own kind of local Remix, and you have like an app. It's like a product over here, right? This is a React app, and this is your contract. And so let's just go make a change. Building rad money and do like the cool emoji. Definitely do cool guy emoji. Where is he? Oh, he's not even in my recents? Come on. All right, so we save that. Now we go over here and we do a yarn run deploy again. That's going to compile, deploy our contract to our local chain, but also inject those artifacts over into our front end. And our front end is going to detect that and say, oh, hey, here's a new contract address right there. Right? We got 8858, right? Let's do that again. And actually, I'm going to turn it up, and we're going to do yarn run watch. And this guy will just run in the background now. So he's just going to detect any change I do here and update you'll see this address update right here as this reloads in. Cool. So there's a contract. Okay. So now we can kind of like mess around with this, right? We can iterate. So we're thinking about making, let's make this function. So what do we have so far? We've got this purpose string. Like, what is the purpose of this? It's programming rad money. We've got this function that we're calling that takes in a purpose and updates it. Well, let's make sure we can do that, right? Can we do that? Oh, no, I don't have any gas. Okay, so you're going to need to copy your address here, go down to the faucet, and send yourself some funds. Now we'll see some funds start to show up. Now we've got $2. You could even go here and send yourself like $100 of fake testnet ETH. Okay, cool. Now I bet if we do a test, there we go. So I bet if we reload this, there we go. So we've kind of have this app now that's talking to our smart contract that's setting some purpose, right? So we could maybe play around with payable, right? And what does that do, right? Okay, well, I just hit save. It's going to compile and deploy. Now it's going to deploy a new contract that we can interface with, but now this function is payable. What does that mean? Well, it means it's going to like want us to send in money when we call the function, right? So we're going to pay the gas, but we're also going to send some ETH right to this smart contract, right? The contract will own it. And so let's do that, and let's put a console log. Let's go full. So let's see, we want the message dot. Ooh, here we go. So we want to say sent in. Look at this console log. This isn't JavaScript. This is Solidity. There we go. So we're going to say the message sender. I don't even know if that's going to work. Let's see. Could be rad. Let's see. Hopefully it will compile and deploy, and we will have some console logs. There we go. Okay, so now we got a new contract, and I'm going to set the purpose to just a single emoji. What's it going to be? Ooh, the chili. Okay, and I'm going to send in how much? One what? Well, that's one way, right? This is another learning experience with Ethereum is there's no decimals, right? So you've got Think of it like dollars and cents. $1 is 100 cents. Well, one ETH is like 10 to the 18 way, right? So if I put in one right here, it's one way. So what you need to do is times 10 to the 18. And since we're in hex, you need to switch it over to hex. If I get that button right. Oh no, it's not working. Oh no. That's not going to work then. No. All right, I got to take this to Hex. Here we go. We're going off chain here. Let's see. So we've got this text input, right? I'm going to paste it in here. And, it's a number, right? So what is that? Number, hex to number. Oh, but I need number to hex. Wait, is there a 2 hex? Oh, there is. Oh, it thinks it's, hold on. Boom, we've got the hex. Look at that. Isn't that handy? Okay, so I'm going to take that. We'll put that in there. And I'm going to hit send. Oh, no. What does it say? Oh, I don't have enough to send. Wait, I have 0.3. I need more. Okay, so let's go to this dude. Let's copy his address. Let's go to the wallet. $100 is not enough because the price of ETH is like $260, right? So what if I send like 500? That's going to be plenty. Oh, okay. So as you're building your app, you're going to have all these nice reusable components that are like in here for you. Like you can have this thing that says $500, but how much is that in ETH? Oh, that's nice. I could just hit that little button and this little ETH input's already ready for you, right? Or you'll notice that thing came up. Or I've got a QR code scanner. Wouldn't that be nice? Okay, so we've got that. I'm going to send. There we go. Now we have plenty of funds. I think this is going to work. Let's find out. Oh, it did. Woo! What's our status? There we go. Now we want to go back to the console log. Check it out. We got a chili in the console log from Solidity. Huh? That's pretty rad, right? No.
Yay.
Yay. Perfect. That's what I needed. Okay, so there we go. All right, so we are iterating on our contract. We're writing code. Sorry, I said it was no code. There's quite a lot of code in this, isn't there? But I did. But if you're getting ready for a hackathon, you're probably going to want some kind of scaffolding to help you get to building a product quickly. And that's kind of what this is for. It helps you just kind of iterate quickly on a contract. And we did have to do some poking, but basically that was that. So we could let's just do something else. Let's set up a mapping from maybe an address to a number. Right. And it'll be public count. And if I hit save, I think this is going to compile. I doubt that I wrote my Solidity correct on the first try. Compiling and deploying. Cool. So now we've got this count and we can ask, what is it? I think we have to ask. So if we ask for this guy's count, I think is how it works. Yeah, it's 0. Cool. So we'd need to like set the count, or maybe we have something that's like, I don't know, we're going to create a function called increment maybe, and we'll make it public. And when someone comes in, we basically take their count for the message.sender and do a little plus action on it, right? You should probably use safe math, but we're just incrementing it. It'll roll right over at whatever 2 to the 256 is.
Can we roll it under too?
We could roll it under. Oh, let's do that. I like that a lot. Let's do a deck, and actually let's seal this up to like a uint8, right? Something smaller. Isn't this fun? We're just playing around with Solidity. All right, so now that's going to roll over at 255, I think. And so if we do a decrement, I did that wrong. If we do a decrement, it should roll us under, right? I like this. We're exploring. Oh no. That's not good. It's like reading the ABI as if there are read functions. What am I doing wrong here? Function, public, what does it need to be?
Use string.
What was that? What was that? Let's see if this will work.
I haven't initialized the com.
The publish isn't working. Let's see. Let's try that. See if maybe I do a different publish here. I don't know why that function's not working. No. All right. Well, there we go. So we can get the count here, but I think so. We were tweaking this contract object very recently, and I guess I broke it. But yeah, that would have been cool to decrement and increment. Let's just keep going here. Maybe if we give it a number. we can say the count equals the count plus the number, right? That'll be cool. This no code shop got really codey. Yeah, let's see what happens. All right, we're at 11:30. If this doesn't work, we'll go back to just kind of open a discussion. Maybe we'll poke around at the DAO. I want to send that thing some money too. I think that would be a fun exercise. Oh, what? Okay, so now if I gave it a number, all right. I don't know. Programming Web3, right? Okay, so what is our number? Let's get this guy's number. His count is 0. So if we want to decrement by 5, so we're going to roll around, right? So what is this going to be, like 250? 251? 251! All right, so something worked today. There we go.
Awesome.
Yeah, right? Let's increment by 100. Boom. Now I'm just getting cocky. All right, it's working. Cool. So this is like a playground. This is a good place to drop in and just kind of poke around at building an application. And you'll see in the front end, let me pull that up. Like I was alluding to with the components, you'll see in the front end that a lot of stuff is kind of taken care of for you. There's the providers that are there. There's a lot of scaffolding here to kind of help guide you through learning how it works and also building a decentralized app. And there's that contract that was doing that stuff, and there's the hints down below. You can look at all the hints here. I don't know if there's anything. Nah, you'll get to it. It's good stuff. So we got providers, we got helpers, the hooks, the components. Okay, let's go all the way back to ETH.Build. Okay, so here we go. I got a QR code for you guys. No. I guess I could paste the address. Could a group of us get some funds into these accounts? Let's see. So we need to get Rinkeby, XDAI, and Kovan funds, and that's what that watcher is doing into this QR code. Can you guys see it? So, oh no, my phone. Here we go. So check this out. So with Scaffold ETH in a day, I put together this thing called an instant wallet. And an instant wallet is like a burner wallet. It's kind of like this simple little. It's got a QR code with the blocky in the middle. You can just go to instantwallet.io and check it out. So I've got $8.38 on there. I'm going to hit send, and you'll see that's the scaffolding UI, right? And look at that. There's a nice little QR code scanner. I'll hit allow. Isn't that nice that that's already all built for me? It allows me to build an app a lot quicker, right? And then, yeah, it gave me the little blocky. Boop, boop. Let me see if I can find that up here to verify. There we go. So same blocky. So let's send this guy, what do you think, 25 cents? 25 cents. Send. Okay, so hopefully one of these accounts increments. Oh, there it is, 25 cents on XDAI, woo! Okay, so now this guy on this blockchain has enough gas, right? I'll leave the other two if you guys can Rinkeby or Kovan your way in. But now we have an account with money on a blockchain. So what can we do with that? Like, let's build a transaction, right? So we'll come off of this blockchain with this private key that everyone can see right now. Don't drain my funds. It's 25 cents. And then we'll go, let's go 2, right? So let's create an ENS box and send some money to AustinGriffith.eth, right? And that addresses that if you wanted to double check it. But I'm going to slide that right into the 2. And then the value will need to be a number. And that's going to be what? 2, it needs to go 2-way, right? This is familiar to you if you've done some Ethereum stuff. Let's see. So it's going to be 0.25, I think. And then that goes 2-way. We're going from way here. So we should have our value right. We can see it if we double click this. Oh, it's going to fill it in for us. But there we go. So that's our value. Data, we're not going to send anything. Gas limit, gas price. I probably have to set that on XDAI. Let's do that. So let's see. Gas price is going to be about that many. No, that's gas. Yeah, that's gas price, right? Gas limit, I don't think I'm going to worry about. I bet it's 20. Okay, we're going to go for this. So let's see. I am going to click that button, and hopefully it signs a transaction. Cool. Do we get a hash back? Oh, what? There's a hash. Let's go to a disinterested third party. Let's go to Block Scout, and let's paste in this transaction ID. Not found. Wah, wah. What did we do wrong? Let's see. Maybe it's just not there yet. See, our balance is there. Yeah, something's not right. Maybe it's gas. What if we send 20 cents? Maybe that gas price is too crazy. Maybe I'm doing something weird. Let's just reload. Oh no. That's going to give us a new. Oh no. Sorry, I didn't keep track. Okay, so this is a good lesson here. I did not keep track of my mnemonic. My 12-word seed phrase, it's gone forever.
Oh.
All right, so here's what I should have done. I should have generated an account, okay? And let's set it up so you guys can't see it. Generate a new account. Okay, oh, look, it looks like a Ninja Turtle. That's Raphael right there. Check it. Okay, so I don't want to lose Rafi, right? So I'm going to get rid of that button for generating, and I'm going to download the mnemonic. All right, cool. So now, yeah, I'm going to have that I can grab. Let me bring that over here, and we'll call it, don't open it, mnemonic, right. And then we'll do, okay, so we need an input. Let's do an input. You can do QR code readers right here, by the way. Let's do an input that's an upload, right? All right. And I drag and drop that guy in. Nope, it's not liking it. File drop, that's what I want. Who built this thing? Okay, so I want the, yeah, there we go. So if I drop the mnemonic in now, yes, we get, okay, so let's reload. Let's make sure before we go sending money to it. I reload, right? I get a new address, right? It's not saved anywhere. We get a new address every time we reload. Bring our mnemonic in. We got Raphael, right? Okay, so cool. Is it Raphael? Anybody know who the orange Ninja Turtle is?
Michelangelo, I think.
Michelangelo. Let's trust and verify. Michelangelo. Points. Okay, so we got Michelangelo here, and we want to send him some funds. All right, so let's see. I'm going to go to, back to Instant Wallet. I could go to Rinkeby or Kovan, but I think it's more fun to send real money even if I lose 25 cents now and then. We're going to scan in Raphael. Check him. Get close. Is that Raphael? All right, here we go. 25 cents again. All right. Now we should have the funds. Now let's figure out what's going on with this transaction. Or did this actually end up being found? It did not. Okay. Well, I don't know. What are we doing wrong here? Gas price, gas limit. I don't think we need to set that stuff. I think we're ready to go right here. Let's see what happens. Okay. I mean, it's giving me a hash from the network. Come on. Okay, so let's see. What network are we on? Let's troubleshoot this. We are on Rinkeby.infura. Why would I do that? Why would I be doing this on Rinkeby? Who, come on. Okay, so we actually need this blockchain because it's actually XDAI. I'm sorry. Transaction here. Wire them up. Snap. All right, we're ready. Any odds on this thing working? Here we go. So we were sending those to Rinkeby. Give us a hash now. Wait, did it give me the same? Okay, I feel like now I'm going to reload. I'm going to go for a freshie. We're going to drop in our mnemonic. It's going to happen. We're going to send value. We got Raphael. He's got funds. Go. Yes, it gives me that same hash. That must be the first nonce. Yeah, of course. Still no. Still nothing. What are we doing wrong? Let's see. Blockchain. What blockchain are we on? Wait. I reloaded. No, it's good. It's blockchain. It's XDAI. We're good, right? This is XDAI. Yep. We've got the right blockchain. We've got the right private key. Data, I'm not worried about. Let's just to be sure, let's send like no data, like a 0x. We're really getting into the mud here. Gas limit, sure. It's going to be a number. It's going to be like what? I don't even care. Like 1 million. No, I probably don't have enough to do that, huh? 100,000. Okay, fine. gas price. Let's just go with 1.001. That's going to be Gwei, right? Okay. From Gwei. Thanks, bro. Let's see. Yeah, looks good. Oh, it did some JavaScripty roundy stuff for us. Okay, gas price, gas limit. We've got it all. This has got to work. Give us some love, XDie. Wait. Let's search that guy. Is that guy ever come up? Nope. This one ever come up? Nope. Okay. I'm failing at a live transaction demo. Welcome to Ethereum. Anybody see anything that I'm doing wrong?
Do you actually need to send it or not?
Oh, bro. Yeah, this is just the signed transaction. Oh man. There's a SendTX box.
Okay, that's cool.
Let's put the signed transaction in there. Let's put so this could be air gapped, right? I could download that, go back to another one. Okay, here we go. We're gonna bring in the right blockchain. All right. Now what happens if we put a button and hook it up to this send, and we're looking for a hash. Ooh, and a receipt. Yeah, that would be good. That would be a good thing to want. Here we go. Click. There we go. Now we got a hash. Ooh, that receipt. Oh, there it is. Oh, it just showed up. Okay, it worked. Wait. Did our money go down? Our money should go down, right? Yeah, we have 4 cents. It worked. I just sent 20 cents to AustinGriffith.eth. So yeah, we were just crafting the transaction there. We were not sending it. That's a good call. You know, you would think that I would know that because I wrote this, but I don't. Any questions? Anything you guys want to try? What are we at? We're about right for just like Q&A session. Someone did mention DAO earlier. I'm not exactly what I could get into there, but any questions? Let's go. Any questions on ETH.Build or Scaffold ETH?
First of all, I need to say it's really cool. I really like this constructor, and I guess it's really a good start for beginners, and it's really interesting for developers as well. So the question probably is, can we write smart contracts here? I have seen that you showed a snippet, but maybe you can show it a little more deep,
Let's do it. Okay, so it depends on if my compiler is working, but maybe. Let's try it. So again, if you're poking around writing smart contracts, you 100% should be using the Scaffold ETH playground that we set up here, the Sandbox, because you can just iterate on your contract right here and have like a live front end here. But let's write some code in ETH.Build for fun too. That sounds awesome. Let's see if it'll work. So we're gonna need a contract called, I don't know, we called the other one your contract too. So we've got your contract, right? And you'll need to feed that in also to the compiler. And then let's make a public, nope. It needs to be a string, right? Public purpose. Look at this. It's our exact same contract. Our purpose will be saying hello, right? Oh, whoops, I don't want to save that. Let's see if this will compile. Not real sure that it will, or if the compiler is even running. I have not tried this in a bit. What do we get out of that? We got nothing out of that. Ooh, I bet if I SSH into ETH.Build, oh yeah, she's dead. Bad timing. Okay, I can actually restart that in a second, but that compiler is probably not going to work for a little bit. It's just like some server that I have that probably gets whaled on. But let's see. Okay. So you can technically write your smart contract, and what it will spit out is bytecode and an ABI. Let's see. I'm just gonna go restart this box because I would really like to see that happen. Any questions or comments as I'm restarting this guy?
Well, since we're gonna build a thing, how How hard do you think it would be to build a thing where we say, hey, here's a couple addresses, and then here's a number, and they can vote on it, and depending on conditional logic, if the number gets above 5, then it goes to do a yay or a nay.
I think that's a great idea. Okay, so we've got some addresses, I think. So do we need to set the addresses first, or let's start over there. So there was a number and people were voting on it. Is that right?
I think we have addresses.
Let's go with again.
I think like the MVP is just that there's a number and then multiple addresses can vote or click to change that number. And then I guess the V2 would be that the amount they change is depending on what their number is. But to start, I think it's just like, there's a number and then different addresses can provide inputs to change that number. And each input can change the number by like 1 or something.
Okay, so it's more like we're going to have a vote, right?
Yes.
Everyone's going to vote on a number. So we'll have a mapping that stores it, and we'll have a function that takes it in. Okay, and it's only a number from 0 to 255, but this will be their vote, and we'll make it public. What's going to be tricky here is going to be iterating through the votes, right? If we do it this way, you have to know the addresses and go get their votes kind of off-chain. If we want to do an on-chain iteration through these votes, you'll probably have a different structure. Let's do this first. I like the V1, but the V2, and it's funny, I go to the Moloch contract every time because it has such good structure on members and proposals. Like the very early Moloch. I'm sure that newer ones are even better, but that's what, if I was going to change this from mapping to structs, I would instantly go Google GitHub Moloch and go find that code. But let's just kind of iterate here. So we're gonna allow anyone to make a vote, and that vote will set their vote, right? So we'll do vote message.sender equals _ vote.
Well, I was thinking even simpler. You just have the number, and then when you vote, you just increment the number. So a vote is just a number increment. And then if the number gets past a certain point, then it could trigger some other thing. Like the simplest possible.
Simple resistance. Right, so we kind of need a Boolean for voters to like basically have a whitelist of who all is in the pool, right? And we can just kind of create that with the constructor. Okay, and inside the constructor, which we'll call like basically when the contract gets deployed, we'll set up a couple voters. So let's just set this guy as the, let's get a couple accounts. These two will be the voters and no one else can participate, because we'll hard code it in here. So we'll require when you make a vote that you have to be one of these voters. Did I get that right? There we go. Okay, so then when you make a vote, and you were saying we'll have a number and then they'll vote to either increment or decrement it. Is that right? So we'll have uint 8. What are we going to call the number? What's it? Just number? Yeah. Okay, and where should we start the number? Maybe right in the middle of the 255, started at like 128, right? Huh?
Sure.
Okay, and so they can vote, and their vote will adjust the number, or it will just adjust it up and down?
Just up and down.
Okay. So like, we're going, there we go. Let's see, so we're going to have our number now, not someone's vote, go up and down, and we're also going to require that the message.sender, let's get this, equals, oh, no. We're going to require that they're voters, right? Yeah. Okay, and if they're not a voter, let's give some feedback to the front end, right? So we're setting our voters early, and they're this guy and this guy, and no one else can vote, and it's hard coded into the contract. We're keeping track of who is allowed. This is probably not the best way to do that. And then we're keeping a number, and we're allowing the voters to adjust the number. There's not, maybe we need one other like has voted, right? We only want anybody to vote once. Has voted, I like that. Okay, and then, so we need to also require that they haven't voted yet?
Yeah. Yeah, otherwise it would say has already voted.
Yeah, and then we'll set that to true right away before anything else happens. Get your re-entrance kind of goosebumps out of the way. So has voted is now true, right? So we're checking that they haven't voted, and then right away we're setting that they have voted, and then we're just going to increment the number by their vote. Okay, so let's see if that will compile. Something tells me I made at least one mistake with, but we're just going to run a compile instead of a full deploy because I bet there's going to be something. Yep. Is it just bool? It's just bool. Thanks for the feedback. Got it. Let's go. Deploy. Oh no. Oh no. Oh, you don't do, what do? Do you do it like this? That can't be right. I think
if it's voters is a single variable or it's like an array or whatever, wouldn't we want to have both addresses in the array rather than?
We're setting a mapping to, we're basically whitelisting them.
Oh, okay.
Right? I think that works. Let's see. We were having some weird difficulties in the front end, but okay. So first of all, let's just make sure it works first, right? Okay, so this guy needs to make a vote. His vote is going to be, oh, he can't do a negative number. What was I thinking? We need to start it at, okay, whatever. They're only going to be able to vote positive. I'm sorry, but okay, so this guy's going to vote 5. Let's see if it goes. There we go. And we see it does go up to 33. Now, if he tries to vote again, have already voted. Okay.
Nice.
Right. Okay. And then the second guy over here, he likes the 5. He likes the 133, but he's going to go maybe 15. Actually, no, he's going to roll it over. Ha! He wants to vote down. Know what he's going to vote? He's going to vote 255 minus 133. He's going to vote 180. Right. That should roll us over. Yeah. Oh yeah. Wait. Yeah. 128 is going to roll us over, that right? So we want to go. He's going way 130, 140. I don't know what I'm doing. Okay, here we go. That should roll it back over, so it'll be under 128 when he votes. Oh, he doesn't have any gas, right? Wouldn't it be cool if we did some GSN gasless meta transaction-y stuff here? Wouldn't that be nice with the UX? Boom! There we go. Hash, and now our vote has rolled around. He has. Nice. Downvoted hard. Okay, now let's do one last check, and that would be make sure I can't as logged in as my MetaMask, right? So boop, boop, boop. Let's make sure AustinGriffith.eth can't vote on this proposal. So, oh gosh, yes, new ethers throw some errors. So you got to, let's see, MetaMask. All right, now I'm logged in as AustinGriffith.eth. Let's make sure I have some gas. He's got gas, folks. All right, now I got plenty. Now I want to vote 10. This is not going to work. This is not going to work. This is not going to work. It totally worked. Wait, no. I don't believe it. Let's go. And it worked on Rinkeby. How about that? Send that one out to Rinkeby. Yeah. Let's go reset this guy too. Man, Rinkeby's just getting all sorts of weird stuff from me today. Here we go. All right. Did we reset that? Okay. All right. AustinGriffith.eth. He's got funds. He wants to vote. He goes for it. Internal JSON error. Wouldn't that be cooler if that gave me more feedback? Did that? Let's see. No, it's probably not even getting here to even see it, right? No. Yeah. Not a voter. Okay, so we see it here. Okay, so that's my bad on the front end. I need to send that message through better. But there we go. So we built a little voting system that allowed some whitelisted people to basically sway the vote.
Yay.
Oh, let's see if our compiler is up yet over on, I think I tried to restart that box. I bet it didn't work, but let's go try it. Usually I have to take it like all the way off in Elastic IP because it's being whaled on. ETH.Build, let's see, how would we even know? Oh, compiler down here. Didn't we have a compiler? Didn't we have some code up somewhere?
Bottom left, maybe?
Bottom left. I'm lost in my own junk here. Oh, there it is. Okay, here we go. No, love. Compiler's down. I will fix that. But basically, you compile here, and what comes out of that? Here. We can kind of do a quick step. Am I okay? Another 6 minutes. We good to do this?
Yeah.
Okay. So what I'm going to do is I'm going to bring these in with that old trusty file drop that we have. So I'm going to bring in the bytecode and the ABI from the contract we just wrote over here. So let's see. I'm going to want to open up packages, Biddler artifacts. Boom, there they are. Okay. And so if I drop in my contract JSON and my contract address, okay, so we should see that's 52D3. Okay. And this is going to be an object, right? So we're going to want to, well, what do we want out of that? We want the ABI. So we want a prop of ABI out of here. Now that should also give us an object. Oh no, I did something wrong. Let's go look at that again. Oh, this is text. We need to parse it, huh? Oh, showing off some neat ETH.Build stuff. We need to parse that into an object. Now it's an object. Now we can grab the prop ABI, and that should give us an object. Ooh, yeah, there's our ABI. Okay, so this is a cool one. So you bring in the contract object, and it's asking for a blockchain, and we will give it XDAI. Oh, no. It would be the local blockchain, right? Yeah, it would be localhost. Yeah. Okay, and we give it the address. Okay, this is kind of magic right here. Hopefully this works. Drop the ABI in here. Boom, cool. So it's parsed our ABI for us, and we can go check. Let's see if someone's a valid voter, right? So let's see if this guy is a valid voter. So that's going to be some text that we'll paste in. There's his address. Slide that right there. Get some output and double click that. Ooh, he is a voter. That is rad. Okay, so then let's do the whole Austin Griffith.eth dance with some ENS. And that gives us my address. And then if I do the same thing coming out of here, checking to see if I am a voter, and it is false. Cool. So yeah, so you can get your contract. Okay, now making a call is going to be different. Let's try, what are we at? 57, I got 3 minutes. Okay, let's take the vote function off of here. So now, let's say I wanted to vote 5, right? So it'd be a number. We want to increment by 5, and I throw that in there. And what I get out of this is actually the call data, right? We need to shove that into a transaction. So I'm going to grab my MetaMask, and I'll unlock it. And let's make sure that's, sure enough, that same guy that's AustinGriffith.eth. And let's pull out that send function. And let's send this data in. Boop. Okay. And let's make sure my network is local, right? Yeah, okay. And let's see, 2 will be the contract address, right? So that would be this guy, I think. Right? Is that, oh, no, that's not right. It's the 05, it's this. Oh, 2 minutes, 2 minutes. There, that's the contract address, right? Yeah. So grab that. I'm not going to send any value, gas, none of that. Okay. This should fail, right? Like basically that's a bad test. We need to redeploy the contract with me as a voter, right? Yeah, it's insufficient funds. That's something else. Let's give me some funds from the faucet. Am I doing that right? Wait, insufficient funds. I wonder if we're on the right blockchain. I kind of don't believe. Yeah, I've got funds. Okay, let's try this. So what do we, 1 minute left. MetaMask signature. Okay, so let's go back to our contract. We want to add a new voter and redeploy. Okay, and that is going to be this fella. And let's make sure I want to get the, I want to do a checksum. Oh wait, I should have used, you can use ETH.Build to do a checksum. Put this into our contract. Okay, now we should have 3 voters, and where's our deploy? Right here. Let's redeploy, compile and redeploy our contract. So now I should be able to vote in this. And what do we have? 1 minute left. Let's see if I can actually make a transaction on our local chain from our Sandbox, but over in ETH.Build for the lols. Ooh, let's see. Still saying insufficient funds. Do I need more than, it must be, let's just send this dude a bunch of funds? I don't get it. Kind of don't believe that. I don't know. Exception thrown. Too bad. Let's make sure this guy can vote. We're so close, but time is out, and I think my stream is probably about over. Any questions, last thoughts, closing statements?
So if people want to learn more and dive deeper into the Sandbox and whatnot, should they just go? They should go to sandbox.eth.build, and where else should they go to see like the tutorials and all the things?
Yep. Yeah. So thanks. ETH.Build is a great place to start. There's a lot of learning content and a lot of me with a bow tie. Once you go into ETH.Build and you hit build, you get sandbox.eth.build. And from there, you've got this kind of bottom drawer here that has a lot of stuff in it, a lot of the education stuff. But I have a hard time like saving these. You'll notice that there's the save and the load and the community. It's still not that sticky, like it needs to be better. But there's a 3-box thing right here. And this is really handy. You can basically log into 3-box and save your builds to 3-box through your MetaMask. And then when you're wherever you are, you can always come back and hit load on ETH.Build and hook your 3-box up to it. So I would suggest that as like a side note about ETH.Build. And then, so ETH.Build, sandbox.eth.build, then Scaffold ETH. So if you just Google Scaffold ETH, you'll probably land here or on the repo. Just go to the repo and go to the quick start. What we did today was like the smart contract Sandbox, do that too. Start building something, and there's tons of tutorials under there that really kind of go through a lot more stuff. And some products that are kind of being built or products being built with this tooling. So there's lots of source code to go look at for examples of, like, say, how to do gasless transactions in GSN or something like that. There's source code for that here.
Awesome.
And thank you for having me. I am at Austin Griffith, and hit me up on Twitter or Telegram. I'm around all the time, up for whatever questions. Especially if you're building something on Scaffold ETH or ETH.Build. I want to see it. I want to play with it. I want to see it. Thanks for having me, guys. Happy Bowtie Friday.
Thank you very much. This is great.
Thank you. That was amazing.
Thank you, guys.
We'll still need to ask you about DAG at some point.
Oh, the DAG. Dang it. We didn't really go through the DAG very much. So the DAG is like, it's available, but I think you have to have like DAG tokens, but I probably have some DAG tokens. So if you just hit me up, and there's probably a channel for this too, I'll just send you some DAG. Let's see. So I think you need to be on XDAI, right? MetaMask. I'm confused. Okay, here we go. Let's go to XDAI. What is it doing? Okay, here we go. So we've got XDAI. I think it's going to detect it. So if you go to DAG.io and then have your MetaMask on XDAI, if you don't have any DAG, so if you do have some, it'll show up in the left. If you don't, hit me up and send me this address right here, and I will send you some DAG. And then once you have some DAG, you can create games, and you can play a DAO-based. It's a game where it's a DAO, it's a Moloch DAO, an early version of a Moloch DAO voting on game mechanics. So you can start with just like I think the first game is like this green world where smiley faces are population, and you can build houses, and those houses generate population. And all of these things are smart contracts running on XDAI, backed by the Moloch DAO, all for the purpose of sort of like experimenting with DAOs and, I don't know, even maybe like microeconomies and game economies and game mechanics and how it could all work and cool stuff we could do. All right, I better head out. I'm probably taking too much time. Thank you for you guys. There's a lot of faces here. I love it. Thanks for coming and checking it out. Happy Bowtie Friday.
Awesome.
Hit me on Twitter and Telegram. Bam. Hearts.
Awesome. Thank you.
Bye.
Awesome. Thanks.